that need one form of energy that convert into the another form of energy. Especially here also we are dealing with the basic fundamentals laws, and that basic fundamental laws that just like in the physics we terms with the many equations. Okay, that electron is moving here, okay, then there is a barrier, then we use the Maxwell equation, then we use something electrons. And what is that? This all is nothing but the physics, what we learn, that physics is itself we have. And that physics and the law of physics is, it is says that it is universally valid everywhere. So, okay, so coming to the point, we are the perfect example of the energy conversion system. And the nature made us that wonderful uh, system within us. So how we implement that wonderful system to develop the other artificial system that we can utilize as a energy resources. That today we will discuss in my talk. So let us highlight our talk. So we will take the introduction of the energy conversion technology, the basic why we needed that, few of the classic examples we will discuss. And there are the different renewable energy technologies such as biomass technology, wind technology, solar and photovoltaic technology, fuel cell technology, waste heat recovery, and among that, how we can choose the efficient technology. So let us discuss what is the type of resources. First, we have the coals, natural gases, oils. These are the non-renewable energy sources that we call the fossil fuels. That fossil fuels, okay, later on the 20 to 30 years, we will feel the biggest crisis. And in that biggest crisis, we will definitely need the one energy source. As a human, we need a food as an energy source. So to utilize our deeds, what we see the technologies went in a high boom. To fulfill that high boom, we need the energy resources. So that the researchers now turn their vision towards the renewable energy. That renewable energy in the form of the utilization of the biomass into the bioenergy, solar energy into the energy, the water, the wine, and the waste heat. So these are the 4 to 5 classes that being going to be used. And also now the nuclear energy also is going to be shifted towards the renewable energy sources. The the basic to control this nuclear energy is still challenging. So the researchers are trying to overcome those challenges. So let us see the global energy used by the sources. First, okay, we are using near about 61% of the coal. We are using around 10% of the natural gases, including diesel and electricity. So around 70 to 75%, we are totally dependent upon the fossil fuel. What if the fossil fuels went off? What we can do? So we only have the renewable energy options. And where it is important. First of all, it is important for our house application. It is important for industrial scale. It is important for automobile. In automobile industries or in automobile vehicles, we are consuming this fuel in a lot level. Obviously, we are making a pollution also. So again, the next, human is finding the extraterrestrial life. They are going to the Mars. They are going to see the planets where the life can begin. So to make such aerospace applications or the space applications successful, we need the renewable energy sources because we cannot provide the electricity from the earth. And then, yes, for agriculture also, we need the energy sources. So these are the wide requirement we have. And to fulfill those wide requirement, we need the one perfect solution. And that perfect solution from where we can extract, that today we will going to be discussed. And let us think about what is the nasty problem again. Because of this using extreme the fossil fuel, the increasing the pollution, then there is the increasing energy demand for each and every aspect. Then if we are taking the example of the electronic devices, there also we need. Then ultimately the goal is we need the green energy production. And for the automobile industry, that what I discussed, and the computer technology. So overall, among these, the main goal to need the green solution from the energy conversion technology. So, okay, let us take the first example of utilization of the biotechnology, that is the conversion of the biomass into the renewable sources. So this biomass is generally nothing but the organic matter that is going to be changed into the bioenergy. It is in the form of, you can say, it is form adopted to one cycle, which is called the carbon cycle. We have plenty of the plants, plenty of the biomasses around us. And let us take one example. Suppose we are taking the corns, we are grounding and processing that corn into the ethanol, and we are using that ethanol into the automobile industries or in the automobile vehicle. So it can consume in the CO2, and that CO2 again, that plant get that plant is going to feed, and then again that reproduction cycle is going to be. So this is the complete carbon cycle that researchers thought, why not to use this biomass? Even the fossil fuels also going to be done if there are the biomass is going to be treated under one specific pressure and temperature for a long time. But for such long time, we cannot utilize in our day-to-day life because our needs are quick. We need the quick. So if demands are the quick, so through the current technology, people try to utilize this biomass, and this biomass in the several form. So first of all, the biomass, if we use the wet biomass, the organic waste and manure, so it convert to the biogas. And okay, then through that biogas, we can uh, use for the heating and the electrical device. Then solid biomass, then we can convert to fuel gas and pyrolytic oil. And then the sugar or the starch plant, through that we can convert the ethanol or butanol, and then we can use for the transport. And ultimately it consumes the CO2, and that CO2 again get to the plants and it get purified. This is the complete cycle and the plan people had made for the biomass. But there is still the big question left. That still big question is that if is it from the chart, it looks like this much easy, then why not the people or the researcher making it successful? There are the certain challenges. And the certain challenges is nothing but the available resources, nothing but the conversion of those first form of energy, that is nothing but the biomass, into the final form. And there are the certain challenges how to process that. And later on, the biggest challenge, how efficient this is. So this all thing we will discuss again. So now let us move to the second form, that is called the wind energy. How we can utilize this wind energy. Okay, we have the natural resources in the form of the wind. The strong wind we can change into the wind energy by utilizing the turbines. And ultimately, this power generation is solely depends upon the speed of the wind. If the speed of the wind is more, the lot of power is there. So comparatively, by looking this, it seems to be it's the really easy technology. Right? We are not going to make the many wind turbines and going to be utilized into the consumption, fulfill our requirement. There are the certain challenges also that we will discuss. So let us take the one example of the UK. UK has the around 9,200 wind turbines. This is a lot of the turbines they are using, and they are producing around 20.1 gigawatts. This is nothing but sixth largest producer in the world. But if we see the chart, how this The production capacity is depend upon where the turbines are located. You will see the red marks are located inside. Those are producing the capacity or the less output. And if you see the big and the green marks, those are on the corners, they are producing the lot. The ultimate reason is that this turbine, it is important where it is located. As we saw, the wind energy, conversion of this wind energy into the electricity, it required the speed of the wind. It depends upon the speed of the wind. And through the location or the populated area, it get affected severally. And because of that, we cannot produce the efficient through that. And then it also affect on the bird migration. If we plant the big wind turbines, so these big wind turbines, it's affecting on the birds and the bird migration and visuals, and also it required must be coupled with the other electricity sources. So these are the certain challenges, and these are not the few, but these are the major challenges that I'm going to discuss with you. So, okay, after learning the biomass energy, we can convert into the bioenergy, but there are the certain challenges. After learning, we can convert the wind energy into the electricity for utilization of us. Okay, there are the certain challenges. Now let us move to the third, that is nothing but the solar technology. And consider the solar technology. Okay, we are know about the solar photovoltaics and the conversion of this solar radiation into the electricity. Beside of that, why we are more focused on this solar technology? So basically, we are getting the radiation from the sun, and we are just wasting that. We are only utilizing, if you say in a day, we are only utilizing 4 to 5% of the solar radiation, and the rest is going to be waste heat, in the form of the waste heat, in the form of, we can say, absorbed by the earth and the atmosphere. So utilization of this solar technology for the heating and cooling in the resident building, for the solar water heating in the agriculture, in the uh, seawater evaporation, so that we can make the extract the minerals also. So in the refrigeration, power generation, and lot of applications that people thought to use this solar technology. So first, the big plants. People means the researcher tried to make the big plants. The big plants. The one example we can say in the Gujarat, uh, in that the river, they plant the lot of the solar photovoltaic cells, and they are extracting the solar radiation into the electricity. So these big plants have these some advantages and some disadvantages. Is that this large comparing to, means depending on this the large cells, it consumes lot of cost, it consumes lot of manpower also to maintain this. Then decentralize. This is the efficient house, what the ideal researcher thought. The efficient house means to totally depend upon the renewable energy sources. The electricity is going to be generated with the solar cell. The wind turbines also going to be used. Biomass also going to be used to produce the bioenergy, and the waste heat also is going to be used. So this is the ideal house that any the presently the researchers are planning to do that. But and in the form of this solar radiation, we can use for the water heating, the air heating, and the electricity production. But there are these some biggest problem to make this technology viable. First of all, the air and smoke, the air quality, the radiation, it gets severely affected. Then the very expensive. So these cells are expensive. We can say if we going to buy to make such efficient house, the one cell cost in a lakh. So to make the one big cell. So now the people trying to reduce the cost, but industrial scale cost and the laboratory cost differs a lot. Then hard to be made for the big hotels, Walmarts, and shopping malls. These are again the biggest challenge. Okay, if there is a problem also in the solar technology to make it to fulfill our requirement, then what is the next? The next is the artificial sun. The artificial sun is going to be just like to our sun if we make the nuclear fission and fusion reaction within a laboratory and make this just like happens in the what the nuclear fission and fission reaction happen in the sun in the laboratory, and we can utilize that for the fulfill of the energy. So nowadays the people are focusing to do this, and this is nothing but going into the China. So this is going to be successful. And what you imagine, what the temperature of the sun? The sun are always going to be heat up around more than 5,000 degrees centigrade. And this, by this, China is being to be successful to make the temperature around of the lakh, 1 lakh of degrees centigrade. So this is the huge achievement still now they achieved, and they are planning to utilize this technology into the renewable energy sources. So this is the future we will see later. So the next is the fuel cell technology. Considering the fuel cell, it is nothing but conversion of the chemical energy into the electricity. And it is the material based technology. As like the solar cell, those are also the material based technology. This is also the material based technology. And when we enter into the material based technology, there are again certain challenges. And those how to make the efficient material. To make those efficient material, when we works into the laboratory, so we realize that how is difficult to extract the, the output from this material. On the literatures, on the papers, or on the news, what we saw, that is different. And when we thoroughly do those investigations, then the certain challenges also come over there. So let us discuss what is this fuel cell. So fuel cell, nothing but need the one anode material, cathode material, and electrolyte. There we need the fuel to provide, to run this fuel cell, that is the oxygen and the hydrogen. So if some of you like to watch the Hollywood movies, and around the 1975 to around 80s, there was the one concept in from the Hollywood, and that the movie's name was the Star War. And in that Star War, they shown the humans are going to be in the space. They are moving from Earth to the another planet, and they are making the big spacecraft. And in that spacecraft, they are using this fuel cell technology. And based on that fuel cell technology, they are moving from one place to another place, and it being the very successful on the movie. And that fantastic illusion made the researchers to focus more on this technology. And after that, this focusing made more certain development, and that development turns this the efficiency of these fuel cells around 40 to 55 in laboratory scale, and the industrial scale, or the we can say in a workable scale, it will always lower down. So let us understand first of all the fuel cell. The fuel cell, as we discussed, there are the one anode, there is the one cathode, and there is the electrolyte material. We are providing the air or the oxygen as a one source to the cathode, and the hydrogen to the anode. So when oxygen migrate through this material, because of the migration of the oxygen ions and interact with the hydrogen, it produces the electrons. And that electron transfer from the anode to the cathode and produce the electricity. So this is the principle behind the fuel cell technology. But this fuel cell is going to be divided based on the material what we use, based on the operating temperature, based on the what fuel we are going to be purged into it. So this fuel cell is going to be depend upon categorized into the polymer electrolyte fuel cell, alkaline fuel cell, solid oxide fuel cell. This is the high temperature fuel cell based on ceramics. Then the direct hydrogen fuel cell and the methanol based fuel cell. But the basic problem for this fuel cell technology is that we need the external oxygen and hydrogen to provide the fuel as a fuel to operate this fuel cell. And it is quite difficult to provide this hydrogen and oxygen simultaneously. So even if we took the means example of the space applications, we cannot hold a lot of cylinders of the oxygen or the hydrogen. In the space, we are not getting the oxygen and hydrogen. Then how we will fulfill? Okay. On the Earth, if we use this air or the oxygen in the automobile vehicle also, and hydrogen also we are going to supply. But this keeping hydrogen and oxygen together, it's just like the one small bomb. So such kind of the accident will make the failure, also will get the biggest failure in this technology. So to sort out these things, okay, there are the certain ways now the people are trying to implement, that is replacing this hydrogen with the another fuel, so which is not going to be converged. So the another challenges, advantages of this fuel cell, it gives the high efficiency, as I told, modular, quiet, non-polluting also, and it combines the heat and power. So the technical challenges, first, the biggest challenges, the materials that going to be solved on the laboratory scale. Then how the better membrane for the polymeric and the dimethanol fuel cell going to be prepared, and the low cost of fabrication for the entire fuel cell. Obviously, the polymer-based fuel cells are the low cost, but the high temperature fuel cell, just like the solid oxide fuel cell, it always have the high cost. So, okay, we learn about the fuel cell also, and it have also the certain challenges. So, okay, what left? Now left is the waste heat recovery. How we can utilize this waste heat recovery into the electricity. So this is nothing but opens the new field that is called the thermoelectricity, the conversion of heat energy into the electricity. And to convert this technology directly from the heat to the electricity, it needs one medium. And that medium, nothing but the materials. So this is also the one material-based technology, as like the fuel cell and the solar cell. So let us discuss about the thermoelectricity. So thermoelectricity, when we put the heat gradient, the one high temperature and one low temperature, because and it generate the temperature gradient. And because of that temperature gradient, it generate the voltage. And there are the physics students understand better. There are the Seebeck voltage. They learn about the electric conductivity. They learn about the thermal conductivity. They learned about the specific heat. They learned about what is the Maxwell-Boltzmann equations, how the transport is going to be. They learned about the semiconductor and semiconductor physics. So these all semiconductor and semiconductor physics you will get to visualize in this field, also in the solar cell. So this we are going to apply and going to extract this physics, the beautiful physics in this subject. So for thermoelectricity, it gets operated into two modes, the power generation mode and the cooling mode. So first, it can utilize, recycle the waste energy. It is highly reliable. It required no maintenance. Once we stack the device 20 to 25 years, we don't need to see. The one classic example you can see around, the NASA has sent the space shuttle in around 1976, the Voyager and the Cassini. And you guys, if you remember, this Voyager just left us our solar systems and went to the deep interstellar space. So how it is going to operate it? What is going to be provide the power to those? Because in the space, neither the solar cell work. In the space, as we discuss about the fuel cell, neither the fuel cell is going to be, it didn't took that much hydrogen and oxygen. So, and also not the biomass and the wind energy. So these space shuttles are going to be operated through the thermoelectric devices. So once it's stacked, it is going to be produce the continuous energy around 20 to 25 years without maintenance. Until and unless we are not making the efficient material and efficient devices. Okay. So rather than the energy consumption, it also worked in the thermoelectric cooling technology. It can use as a refrigerant for the cooling, no noise, precise temperature controller, and fast response. So researchers are thinking to use this technology for the both heat generation and for the cooling purpose, just like to replace our ACs, refrigerators, and where we need the coolant, we can replace that. So, what inspired this present research? So, the this field is started around 1915, and the research is beginning from 1960s, 70s. Then NASA launches the space shuttles, and beginning of the semiconductors, the new semiconductors, and the new physics introduced by the various researchers, just like the biggest name, the famous name, Millie Russell House, introduced the concept of the density of state. As you the physics guys are always aware about density of state, how if we take the example of the semiconductors, in that semiconductor we are classifying this semiconductor depending upon its band gap. So band gap is generally degenerate band gap, not degenerate band gap, and in that also it get classified in the other aspect, whether what is the density of state. If we reduce the size, what would be the density of state? And this density of state is always affecting the carrier concentration, always affecting the production of voltage. So later on, the new materials get developed, and from bulk to the nanostructure research going to be begin. But still, there are the big questions: how we can categorize these materials, how we can understand this electronic structure of materials, how we can understand the atomic scale of the materials, and overall, if we need to obtain the good properties in the thermoelectric material, we need to understand at the nanoscale level. So, uh, the after understanding the parameter within the material, there are the properties which denote the efficiency. And these properties are the Seebeck coefficient that used to generate the voltage, then electricity that used to eliminate the Joule heating effect, and then low thermal conductivity that used to make the large temperature gradient. So these are the three parameters that required within a one material. And it's quite challenging to make combination of these three parameters within a one material. And the reason is that the carrier concentration and the mobility. These are the two factors that the physics people understand better how they are anti to each other. If we maintain the carrier concentration high, we can going to lose the Seebeck coefficient. If we maintain the low carrier concentration, we will lose the electrical conductivity, and also then the thermal conductivity also get enhanced because of the high carrier concentration. So ultimately, these properties have the anemic tendency. They are playing the Tom and Jerry kind of the show within the material. If we play with the one, other will get rude with us. If we play with the other will get rude with us. Then if this is the biggest challenge, and to maintain that biggest challenge into confined into one material, we need to make the one friendly environment. And that friendly environment, by utilizing the physics, by utilizing your hands on the material research, and so that we can make the one good power optimization and the efficiency within this material. So so these are the several classes of the material so far get studied. As you are aware about the silicon, germanium, these are the traditional semiconductors. But when we are going to understand the compound semiconductors, so compound semiconductors classifies into the degenerate semiconductor, and that degenerate semiconductors are frontier and important in these applications. The journey, when the NASA sent their space shuttle, so they start with the lead telluride and silicon germanium material. That time they produce such technology and develop such devices which can make the efficient device to fulfill their requirement. But still, they saw the biggest problem. The biggest problem in terms of the stability of material, the biggest problem in terms of the long-term efficiency of the material. And so far, the research again begins from 1915 to around now and so on. So the different materials get introduced depending on the clathrates, gentle fills, oxides, copper diselenide, and the tin selenide, and so on. And the people are trying to use also now the organic materials, also the carbon nanotubes, graphene. If when the graphene get introduced into around 2004, and but it was predicted around 1985 that the carbon material, carbon-based material, especially the carbon nanotubes and this graphene will turn or will make the boom in the field of research. Okay, CNT somewhat found effective, graphene also somewhat found effective, but when we try generation of the electricity through thermoelectric technology, if we obtain the figure of merit one, then okay, already the NASA has used the for the aerospace application by making the radioisotope thermoelectric generators. If we obtained 1.5, then we can utilize our waste body heat. Means there is no need to charge your mobile. Through our body, we can charge mobile also. That also going to be planned. That technology you will see in the next 5 to 7 years. The most of the Chinese companies and Korean companies are working on that. Then, if we obtain the figure of merit more than 1.5 to 2, we can use this utilization of the waste heat generated through the automobile to operate the cars and like this. Then we can make the hybrid. And also, those people are aware about the research and those who read a lot of news and news. Based on that, always one question keep in mind: if this much is the progress going on, then why one technology didn't fulfill our requirement? Where it is the problem, where we are lacking. So this is the answer. The answer is our thinking is just like this iceberg. We are thinking more than deeper what the iceberg is appearing to us outer. And this appearance of the outer iceberg is nothing but a deliverable what we are getting from this technology. But still, there are a lot of expectation, and still we are not properly understand these things, and that's the reason that our deliverable things are little smaller than that of the thinking. Ultimately, again, the one technology for the by utilizing the renewable energy sources will not fulfill our all requirement. We need to make the combination of these all renewable sources and make one efficient way. So how to utilize this all sources to fulfill our technology? Means only either through the solar cell we cannot fulfill, either through the fuel cell we cannot fulfill, either through the thermoelectricity also we cannot fulfill. So we need to utilize all you can ask what the things generate in your mind. We can discuss on those. Thank you all of you.
That was really amazing.